Hello viewers, welcome to CEC lectures. Myself Dr. Preeti Jagwani. I am teaching computer science in Department of Computer Science, Aryabhatta College, University of Delhi, and presently we are going through a series of operating system concepts. And in our previous lectures, we have established quite a detailed background of what actually operating system is, what is the structure of operating system, what are the modules which are consisting of which are comprising of our operating system collectively, and so on and so forth. So with this background, let us start today's lecture, which is about process management. Now, when we talk about process management, let us try to see first this process management as an entity, or what actually this process management is. So, we can say this is one of the major tasks of operating system, or we can say processes is something which is under the control of operating system, and process management is a module of operating system. It is actually a service of operating system which operating system is providing to hardware and to its user. Now, with this, what actually process management is, we have seen it's a module or it's a major task. Now, coming to what is actually the need of process management. So, let's take two scenarios. One scenario is in early computers, there was only one program which is getting executed at a time, or we can say which is available in the memory at a time. That was only one program. So we can say that all the system resources or all the resources of the system are dedicated to that particular one job or one program, and that one program is having complete control of the system and its resources. But the second scenario is of today's contemporary systems, in which there are multiple programs loaded into the memory. It's not only one single program. There are multiple programs which are kept into the memory, and they are executed concurrently, more than one at a time. So what actually the requirement is, when the scenario has become complicated in case of the contemporary systems, there is required a stringent control on the whole resources, because now there are we can say multiple jobs, multiple stakeholders which are claiming the resources, and then we need to keep these processes separate out also. So we need to have a mechanism of process management. Now, coming to when we talk about the term process itself, what actually process is, and how it is different from program, how it is different from thread, that also we will covering in a short while. So basically, your process is a program which is in execution, which is, we can say, it is a unit of work in the modern time sharing system. So in the time sharing systems, we have different programs, and within those different programs we may have different processes. So the process or the program, actually an entity which is in execution, is known as process. Now, if we want to see process in detail, as far as the structure of the process is considered, let's see what actually the process is. So, operating system considers something as process with at least two entities. One is the executing system code, and another one is the user process, which is executing the user code. So operating system processes could be the system code which is being executed, that's also a process as far as operating system is concerned, and another thing is user processes, which is executing the user code, that's also is operating system process. Now, these two things, one is the user process, another one is the process which is of the system. It is a perfect possibility that these can execute concurrently. Now, who is responsible for execution? It's the CPU. Now, in multi-core systems like today's, or in the systems which are available today having more than one CPUs, these one CPU or more than one CPUs are actually multiplexed among the processes available, and all these processes are executed concurrently. So now what is actually happening here? We have, let's say we have one CPU. Presently we are considering the scenario of one CPU. We have one CPU, and there is switching the CPU, there is a process of switching the CPU between processes in order to make the computer more productive. So let's say, for example, there are, let's say, two processes, and one process is taking the control of CPU, and suddenly an input output kind of operation is required in order to proceed further. So that process is going to go for input output operation, and then meanwhile when CPU is sitting idle, CPU will take other process and then start the processing of the second job or the second process. So that means what we have done here is we have reduced the idle time of the CPU. That way we are making our computer system more productive. Now, so even on a single user system, if you can see, a user can run several programs at one time. So let's take an example for consider the instance that a media player is playing some songs in the songs in the background, and then I have given one command of printing some 100 pages onto the printer. That thing is also going on, and meanwhile I am also composing an email. So basically 3 processes at a time are running, even if the system is having system is actually a single user system. So or it could be another scenario in which embedded devices are there, and these embedded device, please make a note of it, that embedded device does not support multitasking. So even if multitasking is not supported, we may have activities such as memory management or something of that sort, which is actually an internal programmed activity. So what is the fact which I am trying to establish here is, it is a perfectly possible and a valid scenario, and it's a kind of very very frequent scenario in which only one activity is not working. There are many activities and there are many processes, I can say, which are going on. Even if it is a single user system, there can be multiple processes going on. Even if it is an embedded device which is not supporting the multitasking, one program at a time is being supported. Operating system in the background, in the internal system, needs to support a lot of programmed activities such as memory management. So there is always kind of more than one processes which are going on into the system, and all these activities are you can say all these activities are jobs, or you can always say all these activities are processes. The term jobs and processes are used interchangeably in the literature, we can say. Now coming to we have established why this process management is needed. So even in a single user system, or even in a system which is based on non-multitasking, or even in a multi-user system, the scenario is very clear. We have more than one processes. So more than one processes competing for some resources like memory or something of that sort. They are residing onto the they are residing in the memory. They are competing for CPU as well. So this may create conflict if not managed and controlled properly. So there is a kind of, we can say, essentially the process management module is required. So till this point, what we have learned is what actually the process management is, what do you mean by the term process, and the third thing which we have seen is what is the need of process management in various systems. Now coming to let us try to see the details about the process. So details about the process, if we can see, let us try to explore the structure of the process. So when we talk about that this particular program in execution is a process, so what will be the structure of that process, what that process is going to contain. So a program process consists of, one is the text section, which is more than the program code. It is not only the program code which is being consist here, it is also the text section Then it is also having the current activity as represented by the value of the program counter. Program counter is something which is going to represent what is being, what is the current activity which is being executed. Then apart from that, it is also having the contents of processors registers. For CPU, they have some specific registers in which some values are stored or some data is, we can say, stored. So the contents of processors registers is also consist in the process. Apart from that, it also includes the process stack. This process stack contains temporary data such as function parameters, return addresses, local variable. Now here please recall, in the data structure course we have gone through the stack, and we have also seen that in case of recursion or in case of functions, a stack is something which is more commonly used. So here is that stack, that memory area which we are talking about, that contains temporary data such as function parameters, return addresses, local variables, and so on and so forth. Apart from this, program section, then the current activity, processor contents of the processor registers. The process stack also includes, the process also includes the process stack. It also contains a data section which contain global variables. So we all know global variables is something which is global to all the modules of a program or an application. Not only this, it also contains a heap from which the memory is dynamically allocated during runtime. So recall that in the series of C++, we have gone through the dynamic allocation of memory, which is done through the new pointer, and the dynamic deallocation or freeing of the memory is done through the pointer free. So that is the memory which is coming from the heap. So a process contain all that. So a process contain basically program code, which is basically a text section, the current activity as represented by value of PC, which is program counter, the contents of the registers which are available with the processes, then it is also having a process stack, then it is also having a heap, and apart from that it is also having a data section. So if we want to have a look that how this process looks like, or how all these elements are arranged. So here is a figure of a stack in which you can see, here is a figure of the structure of the process in which you can see there is memory starting from 0 to max. So that's the number of memory cells it is kind of occupying. Then the first section consists of the text section, which is basically the program code. Then you have data, and this data also contain a global variable in a separate subsection, we can say. Then we have two structures, one is stack, another one is heap. Heap, as I told you, is required for dynamic memory allocation, and this allocation goes from top to bottom, that is goes from lower limit to higher limit, while the stack, this being a LIFO structure, grows in the downward direction. So that's why there are two arrows, one is from stack which is going in the downward direction, other it is from heap which is going in the upward direction. So your process is going to have all these elements. So this is basically the structure of a process. Now, as I have told you, program is by itself is not a process. That means, as in program, if it is not executing or if it is not active, it is not a process. Basically, a program itself is a passive entity. It is just like a file containing a list of instructions stored on the disk, while your process is an active entity which is under execution, we can say. And it is also having a program counter which is specifying the next instructions to execute. It is also having a set of associated resources. So there is a difference between the program and the process. Program being a passive entity, process is an active entity with program counter with a set of associated resources. So this is what we have seen, what is the what actually the process is, what is the structure of the process, and then we have also seen what is the difference between the process and the program. Now coming to the state of process, or we can say process state. So process state, something which is kind of in order to initially in order to begin with, we can say a process when coming into the system, it is considered as a new process. When it is going out of the system, maybe after because of an error or because of a because of the completion thing, it is going to be called as the process which is terminated. So basically there is a difference between the state of the process. And now why this state of the process changes? This is just because of the process execution. So basically I can say as the process execute, it is going to change the state. So process state is basically defined, we can say, by the current activity of the process, but not fully, partially. So process state is defined partially by the current activity of that particular process, and when a process is executing, it is changing the state as well. Now coming to the details of process state, that how many types of process states will be there. So basically we can say there are 5 types of process states of the process. One is new, running, ready, waiting and terminated. I repeat here, new, running, ready, waiting and terminated. Now this terminology may vary from one operating system to another operating system, and all these states may also vary. Now coming to when it is going to when your process is going to be in which state. So let us first consider the state of a process which is new. So the process is just being created, it is not kind of allocated anything else, so that the state of the new process. Then when it is being executed, instructions related to that process are being executed, then we say the process is in the running state. Now let us say your process is running, and meanwhile it requires some kind of an I can say interruption from input output devices, such as an input output completion or reception of a signal, or maybe kind of receiving a data from input output devices. That means now your process is not getting executed by CPU, but it is going to wait for some event to occur. It could be an input output event, or it could be an a signal event. So that is what you call the waiting state, in which your process is waiting for some event to occur. It is not running presently. Then we have ready. So ready is something or a state in which the process is waiting to be assigned to the processor. So either your process when created was new, and then after its we can say preparations, it is now waiting to be assigned to the processor, that is known as the ready state. And finally the state of termination, in which the process has finished execution. So again I am repeating, the process may be in one of the following states. One is new, another one is running, next is ready, the fourth one is waiting, and the fifth one is terminated. So new is when your process is being created, that is the new state. Then we have the process of the state of the process running. That means your process is currently occupying or currently taking the CPU, and its instructions are being executed. Then we have the process which is in the waiting state, and it is waiting for something to happen. It could be an signal interruption, or it could be an waiting for an input output event to happen, or some input output completion activity it is waiting for, or something of that sort. Then we have the next, which is ready state. A ready state is process is ready, but it is not being assigned the CPU yet. So, the process is waiting to be assigned to a processor. That is the ready state. And then the next state is terminated, and in which your process has finished the execution. Now, as I told you that when a process executes, it is inevitable that the state will be changed. There will always be a change in the state when your program or when your process is under execution. But please remember that there will be only one process which can be running on any processor at a time. Other processes which are even loaded inside into the memory may be ready or may be waiting. So, only one process can be in the state of running. Other processes will be either in the state of ready or in the state of waiting, or maybe they are new to the system, they have just arrived, or they are terminated, that means they are already exited. Now, if we want to see how your process is going to switch between the various states, or how these states of the process are going to be changed. Now, let us say we have the first at the first instance we have one process which is just kind of submitted or just admitted for taking its share of CPU, or it has requested a share of CPU. So, that is the new process. Then after becoming ready to get the CPU, it comes under the ready queue, or it comes under the state of being ready. And here we also have one queue which is known as ready queue, and that ready queue is managing all the processes which are ready. So, after this ready state, the process will go to the running state. So, here you can see this in the figure. The left side, the first entry is the new, the process is being admitted. Now, process is ready to catch hold of CPU. Now, the moment it is going to get the CPU, the state of the process changes from ready to running. So, there is a we can say a change in process state. Now, while running this process, it may need an input output activity, or maybe another signal or an event. Then in that situation, what will happen? This process will come from running state to the waiting state. Now, why? Because this is now waiting for one of the events to happen. So, now this is in the waiting situation. Meanwhile, CPU will be taken by any other process, I can say, which is again going from ready to the running state. Now, the process which was in the waiting state, that has completed its event, or that has completed its input output, and now it is again ready to get the CPU. So, now from waiting, if you can see the lower U-shaped figure. So, from running to waiting, and then from waiting to be ready again, because now the input output or the event has been completed. So, now again it is submitted into the ready. Now, we have seen one scenario in which a process can go from ready to running state. There is a scenario in which your process may go from go vice versa, that is from running to ready state, and that is the event of an occurrence of an interrupt, which is being I can say there is an interrupt which is going to be there. So, then your process which is running is interrupted, and now the process is again into the ready state. Now, it is not waiting for any input output to happen. Would have been the situation, it will go to the waiting state, but the process is ready, it is complete, it is kind of, we can say, ready to get the CPU, but it is interrupted somehow because of an interrupt. So, in this situation it will go from running to ready. Then after getting this CPU for let us say for its time or for its execution. So, somehow the execution is completed. So, when the execution is completed, your process will exit from the system, and now the state will change to terminated. So, here I am repeating it once again. From new it will go to ready. From ready it will go to the running state when it will have the CPU. If an interrupt occurs, it will go to the ready state again, and if an input output or event waiting situation has happened, it will go from running to waiting. After getting over with that wait, after getting that event, after getting that signal, or after getting that event completion, it will be again submitted to ready state, and when the job is completely done, it will go to the stage of terminated. So, all these 5 stages will be kind of switched in between. Now, one thing which is very important to note down here is a process which is getting entry into the system is not going to have directly, it is not going to be submitted directly to the running state. First it will have to be it will have to wait inside the ready queue, which is the queue of all the processes which are ready for the CPU to catch hold of. So, it will go to the ready state. From new it can never go to the running state. From new the state will be ready, or it could be waiting if it initially needs some input output event, which is kind of less unlikely. So, from new it will go to ready, and then from ready it will go to running, and then it will get terminated. So, in this lecture what we have seen till this point is what actually the process is, what is the difference between the process and the program, then what is the need of process management, what is process management, and what are various states of processes including all its 5 stages. And here is the list of references which is being used for the preparation of this lecture. Hope you had enjoyed it. Thank you for a patient hearing.